The last major section of this module, we're going to talk about exponential and log equations, and then we'll do some applications. So I'll start with, I'll just do a kind of a short one here on solving exponential equations when you can write the bases the same. It turns out that if you know that if you say a to the m is equal to a to the n, where these two bases are the same, then the two exponents must be equal. So let me show you an example of that. So if you have 5 to the 2x plus 1 equals 1/25. Now you could solve these using log application I'm going to show you later, but let me just show you, you don't need to use logs here because you can actually write 1/25 as in the same base as this expression over here, because 1/25 is the same as 1 over 5 to the second power, and 5 to the second power can be written as 5 to the negative 2 power. So now you have the same base on both sides, and so since you have this base to the 2x plus 1 must equal this base to the negative 2 power, then you know that 2x plus 1 must equal negative 2. And then all you have to do now is just solve for x, and so subtract 1 from both sides and you get 2x equal negative 3, then divide both sides by 2 and x is negative 3/2. So that's how you can solve that one. I'm going to go ahead and give you one more that's a little more complicated, but here you have 27 to the x squared power equals to 9 to the x power. Now you can actually, even though you can't raise 9 to a nice power to get 27, but you can convert these to the same base, because you can actually replace 27 with 3 cubed, and you can replace 9 with 3 squared. So instead of 27 to the x squared, I have 3 cubed to the x squared. Well, then I can use my properties of exponents that I told you to review, and I can just multiply these two exponents and get this as 3 to the 3x squared power, and then over here I can multiply these two exponents and write this as 3 to the 2x power. So now I have the same base on both sides, so therefore these exponents must be equal. So to solve this equation 3x squared equals 2x, I'm going to subtract 2x from both sides, and that'll give me 3x squared minus 2x equals 0. Then I'm going to factor an x out of each, so I'm going to solve this by factoring, and I'll get x as a factor and 3x minus 2 as a factor. So the only way this product can be 0 is if x is 0 or 3x minus 2 equals 0. Well, x equals 0, that's basically your answer for one answer, and then you solve this equation and you get x equal 2/3 for the other answer. And so you have two answers for this problem, x equals 0 or x equal 2/3. Now I'll show you how to solve some more complicated problems using logs on the next video.